Hello, everyone, and thank you for joining us today. We know that you're very busy, and we really appreciate you choosing to spend the next 45 minutes to 60 minutes with us. We have a very interesting webinar prepared for you. And in today's webinar, we will examine how a native parallel graph can improve supply chain performance. I'm joined, my name is David Ronald. I'm the Director of Product Marketing here at TigerGraph, and I'm joined by two colleagues from TigerGraph and two friends from Expero. The person who will speak following me will be Gaurav Deshpande, who's my very capable manager, Vice President of Marketing with an illustrious history. And also we have Kevin Kai, who's a software engineer at TigerGraph. We also have Brian Thompson, who is a Vice President at Expero, and Chris LaCava, Vice President of Product at Expero. Just a quick item on housekeeping. This webinar is being recorded, and we will send you the link quite soon after the webinar concludes, and we'll also post the webinar on the TigerGraph website in case you need to drop off or whatever, or want to share with friends. You'll have the opportunity to do so quite shortly after the webinar. The phone lines are muted, but we do want to hear from you. So I really encourage you to submit your questions, and the way to do that is through the Q&A tab in the Zoom user interface. And we'll have time at the end for questions, so please submit them. And we may also take a few questions during the webinar itself. So without further ado, I'd like to hand things over to Gaurav.
Thanks a lot, David. Hi, everybody. First of all, it's good to have so many people on the call. I'm always excited and interested to see the interest from data scientists, from developers, from architects, as well as business users that are involved in supply chain management. I started my career. My first startup was supply chain management, i2 Technologies. Some of you who've been around long enough in supply chain management will recognize that name. So I built out i2's supply chain planner product and demand fulfillment product that's been used by 300 out of top Fortune 1000 customers in production. I have several patents in supply chain management. So when we started looking at TigerGraph and how to apply that for supply chain management, my question was the same one that all of you have on your mind. Supply chain management is a fairly established field with multiple players, multiple solutions. What is it that new that you bring to the table? And we will answer that question today in today's webinar in a good level of detail. And then some of you have already requested follow-on briefings, so we'll schedule those with you to figure out how you can improve your current supply chain management stack, how you can connect it to other systems, and you can use TigerGraph to do that. I have Kevin on the phone with me along with Brian and Chris. Kevin, would you introduce yourself? And Brian and Chris, would you take a couple of minutes to introduce yourself?
Sure. Hi, my name's Kevin. I've been with TigerGraph for a little over a year. I'm currently a software engineer on the solutions team, and I'll be going over a short demo with you guys today.
Hi, my name is Brian Thompson. I've been with Expero for about a year, and I work a lot with Chris LaCava. I'll be providing a little bit of background on some of our experience and some of the customers and prospects that we've been working with in the supply chain space, and some of the challenges that they're running into. And I'll be turning it over to Chris.
My name is Chris LaCava. I'm a user experience designer by training, I guess. I work on products here with Brian at Expero. I've been with Expero for about 5 years, and I'll be demoing one of our product toolkits with a sample supply chain demand and capacity planning data set to show how we can visualize highly connected data from a graph.
Excellent. Let's go to the next chart, David. Excellent. So we already covered the introduction. Let's go to the next chart. Would you take it away, Expero team, and then I'll add a little bit of a context around supply chain management and graph specifically.
Yeah, sure. Just a super high level on Expero. We were founded in 2001, and we build software and tools for expert users in general. That covers a large space and a variety of customers, but we're about 50-50 split between very technical front-end and back-end developers, and then user experience and designers. And so we're very often combining complex problems with very large data sets and graph databases and machine learning with an interaction layer that makes sense out of that complexity and allows users to interact with it. So that's a bit about where we come from. If we go on to the next slide, we'll see, again, it's across a variety of industries, wherever there are large problems. We'll talk today and focus on supply chain, but these problems certainly span a number of industries. We have lots of customers in the biotech space, whether that's around experimentation and running labs, or whether that's around finding and tracking diseases like MRSA as it spreads through the population. We've done some work there. Lots of stuff in high tech, software and hardware, and then especially in the graph space, lots of work in defense and justice with looking for fraud and finding bad actors. So these are just some of the areas that we've done some work in. If you want to go to the next one.
All right, I think knowing how well Expero knows us, I think they can pitch this chart as well. Most of the people here on the call know us already. We are the de facto graph database when you need a scalable graph database. In fact, we are the only scalable graph database for the enterprise, used by some of the biggest Fortune 500 companies, as well as innovative startups that want to build a highly scalable solution. Let's go to the next chart. So customer base has expanded very rapidly over the last year. We did 400% in customer base expansion last year. And TigerGraph Cloud that was just launched 3 weeks back, we already have hundreds of customers using it. So it's going to grow multiple fold. We're also seeing an interesting trend where a lot of Fortune 500 companies, their different departments that are understanding graph and learning graph are joining TigerGraph Cloud. They might deploy those solutions on premise in their own data centers or in their own cloud, whether it's AWS or Azure or GCP. But they are doing, this is providing a great place for people to learn and start to build out their proof of concept. So I'll ask all of you, if you haven't already, to check out TigerGraph Cloud. There's a supply chain analysis starter kit in there for you. With that background, let's go to the next chart. Let's go directly into now the challenges of supply chain, what hasn't been solved, because as I mentioned, supply chain analysis is a fairly well-established industry. Let me ask my colleagues at Expero to cover some of the challenges they have seen at customers, and then I'll add more perspective from our customers with respect to what Graph can do.
That's great. If you want to just pop into the next slide. It's an interesting space. There are lots of systems in the supply chain area, and for the most part, the people that we talk to, the individual systems are functioning, and if not perfectly, they're at least getting by and solving problems. And if that's specifically in the areas of purchasing or manufacturing or inventory management, there's tons of these warehousing, transportation. In general, folks have systems in these areas, and those people are functioning okay. And where the challenges lie is especially as the problems span these areas. And it begins to get very complicated. As we go into the next slide, the data sets are huge. They're spread out across those systems as well as upstream systems and we'll talk a little bit about that, but whether it's the various ERP systems or any of the functional supply chain systems. But they're disconnected, and at the same time, they're highly dependent on one another. One data extract feeds into the next system down the line, and there are lots of dependencies, whether it's the source materials and the components and the ingredients that contribute to subcomponents and then on to products and finished goods. Each of these layers and each of these sources is interact with the next, and then as items and materials are produced and then need to be either shipped off to customers or intentionally put into inventory in various warehouses, tracking them through that process becomes very complicated. And then as we go into the next slide, we'll see that most all of our customers are dealing with an SAP and or an Oracle, other ERP systems, but inevitably with all the systems that they've purchased and that they've built in-house, they have hundreds of users who are trying their best to extract that information based on IT reports or based on little data connections that they've built, and they're compiling that data in their own environments and spreadsheets. And so the access that they need and the ability to kind of clean up things or bring two different data sources together just doesn't exist. And inevitably, almost everyone, if not everyone that we talk to, has ended up with hundreds or thousands of spreadsheets around their organization trying to compile these highly dependent pieces of information and make sense out of them. And they're inevitably spending lots of time on that, but they're missing critical components, and it's not real time. And as we move into the next piece, it's largely as a result of all those dependent data components and pieces. And so it's a very difficult process to manage. It's a very large amount of data to try to make sense out of. Inevitably, there's a lot of aggregation that needs to take place in order to figure out even where to start or where to look. And it's inevitably a lot of time is spent and a lot of insights are lost. More time is being spent on the logistics of moving that stuff around and trying to get to just the necessary pieces of information to do a very tactical thing. And the time to see across the broader picture of what's going on is just not there. The supply chain space is a very dynamic world. As we move into the next slide, we're constantly trying to figure out when something has not gone exactly as planned, or when a much larger order than expected came in. How do we handle that? And trying to create the necessary kind of what if scenarios and do the analysis that this order just needs to be pushed off until next month. We're almost never making the optimal decisions. We're going on gut instincts in a lot of cases. And better process through these alternatives that are available to us. So these are some of the, I think, most frequent cases that we run into, and actually, I think, kind of the basis for the need to pull all this data together into a place that can handle the volume of data and the complex set of relationships in order to then interact with that data in a sensible way. If you want to hop over into the next slide.
All right, thanks a lot. Let's look at what Graph can do here, right? And I'm going to give you a very high-level overview. I know some of you have already requested meetings for a deeper dive. We'll do that. So this will give a taste of what Graph can do today. And then as you look into it, as you see the business need connecting up, we'd love to have deeper conversations with you. And there's a model that Expero has proposed at the end to do a little workshop. We can certainly discuss all of that stuff with you one-on-one. Let's go to the next chart. So in terms of, can we go to the next chart, David? Hey, can you hear me? Can we go to the next chart? Excellent. So let's skip over some of these introductory chart everybody knows that you're using LinkedIn every day. It's a classic social relationship graph. LinkedIn has built in their own proprietary graph, which is fairly old and long in the tooth by now, but you use it every day. This is an example of that. Let's go to the next chart. Another example of graph-based analytics, PageRank, and I'll bring it home for you on supply chain analysis, how it relates there. But every time you're using a Google search, you're essentially using PageRank algorithm, which is a graph-based algorithm. What you're trying to do there is find the most influential web pages that are referred to most by other web pages. Same concept can apply for supply chain analysis when you're trying to find the parts, critical parts that are used by most amount of sub-assemblies or equipments in your portfolio. So depending on your portfolio, whether you're producing heavy equipment, complex industrial equipment, you're producing automobiles, or you're producing any other type of sub-assemblies, you can look at finding the most influential, most critical parts using PageRank, which is an algorithm that's also used by Google on an everyday basis, and you're using it every day. Let's go to the next one. Really, many of you understand this, but at a high level, Graph 1.2, single server graph. Graph 2.0 built on NoSQL backend, and Graph 3.0 is where we shine. TigerGraph, native parallel graph that's highly scalable. You can shard the data and you can distribute the data. Take terabytes of data, distribute it into smaller commodity servers, and be able to scale that up. And I'll relate it to supply chain management in just a moment. Let's go to the next chart, David. Six key facets about TigerGraph as you're looking at supply chain analysis. We are talking about connecting up your own supply chain with all of the other supply chains. So I'll give you an example. You're talking about supply chain, your own supply chain data. You're looking at your vendor supply chain data, the ones that you have contracts with. You're looking at forecasts that are coming in from different channels and different distributors, as well as your own forecast. You're looking at your commercial system that are running promotions. We have the ability to take in all of those data sets, and we have the scalability to handle connection across all of those data sets. The transactional or mutable graph really pertains to supply chain management, where you can have these updates coming in real time and get attached to your master graph that contains your end-to-end value chain, whether it's your own supply chain inside your own factory or your distribution centers, or data that's coming in from the partners. You can connect up all that stuff in real time with transactional or mutable graph. Real-time performance and deep link analytics is really the bread and butter of TigerGraph, where you can understand impact of something like, for example, if you have a particular hurricane headed to one of your suppliers, that supplier's factory provides a set of critical parts that you use in most of your assemblies. What's your plan to respond to that particular thing, given that there'll be an outage for a few days or few weeks following that hurricane? To deal with that uncertainty, we can provide real-time analysis of impact propagation across understand all of your products that will be affected, look at the forecast for those products, look at alternate suppliers, and plan out your alternate plans of getting that critical part from another supplier. So we can do that analysis in real time across multiple hops or connections in your supply chain. Your current solutions will struggle to do that at the same scale and speed that TigerGraph can. Lastly, you have Graph Studio, which is your visualization environment. You'll see that today, Kevin demonstrating with it, as well as Graph Query language that's specifically purpose-built for doing massively parallel processing and computation. Enterprise-grade security is table stakes for TigerGraph, given that we were born out of the need to build the most highly performant, scalable, and secure database for graph purposes. And that's something that you'll find at TigerGraph. And it's useful for you because your supply chain information has sensitive data. We'll make sure that we do role-based access with multi-graph, for example, that would allow people who are supposed to see a particular information, such as promotions, will see only promotions, and they will not, other people will not have access to sensitive data like pricing and promotion. Let's go to the next chart, David. This is about speed. Speed means nothing if you can't translate it for something that is for customers. In our case, our speed basically translates into lower cost of ownership for you. for the same machine, we can handle 40 to 300 times the workload, which essentially means that we can able to do the analysis much cheaper for you. Let's go to the next chart. Let's go to the next chart, David. Can we go to the next chart? Can you hear me? So on the, I'm not sure if it's able to hear me. Hey, David, can you hear me? Can you go to the next chart? Next chart, please.
We can hear you. The click through may be a little slow.
Oh, okay, there you go. Thank you. No problem. 7 key capabilities here. Deep link analysis. This is where you're trying to understand relationships between different entities. I mentioned the example of a critical part that a particular supplier has, or a set of critical parts that are supplied by a supplier. They're located in the hurricane area that's going to be affected over the next several weeks. How do you understand the impact of that? That's what deep link analysis is. Entity and pattern matching can be applied, the second category, second capability in graph databases very well to supply chain. I'll give you an example. When you're trying to find a particular type of thing in your supply chain that leads to delays in delivering the goods or getting goods produced on time, that's a good example. When you find that particular pattern, you can look across your data set and find those repeating patterns, the good patterns as well as the bad patterns. The good patterns are the ones that allow you to deliver and produce stuff sooner and deliver stuff sooner, and the bad patterns are the ones that lead to delays. You can do all of that matching using TigerGraph with pattern matching capability. The relational commonalities is all about understanding what's common between your different portfolio products. So when you're looking at different types of products that you sell, what are the common parts, right? What are the parts that are what are the suppliers that are common between those products? That's what relational commonalities is for. So it's highly useful for you as you're trying to connect up your suppliers with your products, with your locations, and with your demand forecast. You can find commonalities to identify the most critical points in your supply chain and address those. Hub and community detection. Hub, as I mentioned, is PageRank, where you can find the most critical parts, most critical resources within your supply chain. And then community detection is everything that's connected to those. So both of those are useful for you. Geospatial graph analysis, I don't need to tell you guys who are in supply chain management. You're trying to understand how the goods and services are moving across different geographies. And the geospatial analysis is something that we can do for you across any level of complexity in terms of your geospatial matrix. Time series or graph analysis, where you're doing time-based graph analysis. Your supply chain is not static, right? Your products are not static. Your suppliers network is not static. All of it is changing, and its relationship is changing with respect to your products and your locations. We can model that, and we can do temporal analysis for you to help you understand what is changing in your supply chain over a period of time. Another useful feature and something that your current systems cannot handle. The last one, machine learning and explainable AI, is something that is an early stage right now with supply chain management. What you're doing essentially there is doing relationship analysis to understand relationships between your products, your locations, your suppliers, and generate relationship-based features that will feed your machine learning. This is early stage. The 7th capability is not well fleshed out right now for supply chain management, but we'll work with you to figure out what your requirements are and design the right features for you. Let's go to the next chart, David. So main thing to look at with respect to supply chain management, right, is what are the things that we can do? We can do deep link analysis for you, and we can understand impact of one thing and carry it all the way through 10 or 15 levels of hops. That's the first thing we can do for you from a supply chain management perspective. Second thing we can do for you is you have different domains, different types of data sets. I'll give you a specific example, and you'll see that example played out today as a part of Kevin's demonstration. Let's say you are running you're looking at all of your sunroofs and moonroofs. Let's say you're an automotive manufacturer and looking at your sunroofs and moonroofs. You want to understand, you have a certain commitment with each of your vendors in terms of volume commitments. As a part of those volume commitments, you're trying to understand what percentage of volume commitment I've already met in terms of dollar terms and in terms of specific parts consumption, and what remains. With TigerGraph, you can do that analysis in real time to understand where you are at every single day of the quarter, to say, I have 30% more to go for this particular vendor based on their volume commitment. I have 40% to go with this particular vendor, and I have only 10% to go for this particular vendor. What that allows you to do to avoid penalties that are associated with not meeting the volume commitments. So that's one of the things that you will see time and again that TigerGraph is used for, is to understand how your supply chain data and your forecast for what you're forecasting to produce, how does that jive with your commercial side of the house, and understand if I need to consume more of the sunroofs or the moonroofs, can I run specific promotions and offer customers a discount so more customers will buy those, and I can then get delivery for those from the vendor before the end of the quarter so that I don't have to pay a penalty. So I would much rather pass along that benefit to the customer in the form of a discount, and I'll still pay only half of what the penalty would look like. So that's an example of connecting your data from your supply chain to looking at what the vendor commitments are, and then figuring out promotions that are appropriate to stimulate the demand, to shape the demand and drive additional consumption. So those are the type of examples that we will talk about today. Without further ado, let me hand it back to the Expero team for them to cover that. So actually the slide hasn't changed. David, would you go to the next chart? Can you go to the next chart, David?
Sure. We're having a problem with the Wi-Fi here, so I think I'll pass control to
you can pass it to Chris.
Brian or Chris, if you wanted
to. Yeah. Just give it to Brian.
Control.
Yeah, that's right.
Yeah, I'll just do a quick kickoff. We'll jump into a little bit of a demonstration quickly. We're gonna talk about planning, and planning is a rather enormous set of processes in the supply chain, and it starts with, or depending on which way you want to go, you can talk about executional level planning, which is happening on a daily basis, certainly daily and weekly across scheduling, dispatching, ordering, those types of things. And it goes from executional into operational, into tactical, into strategic as you move up the process, and you move from days and weeks to months, and then quarters, and then years over those different time spans. And what we're going to talk about today is going to sit more in the realm of what's known as aggregate and or rough cut planning. It's going to be the type of things that happen over a 3-month to 18-month time horizon. In some place, some of our customers are doing this as far out as 36 months. It's a process that happens in advance of the actual executional type planning. And so that's to set the stage, and I'll turn it over to Chris, who's going to share and demonstrate for us.
Okay. And while we're waiting for some of the AV stuff to clear up, I can kind of set the stage for the demo itself. As Brian mentioned, we're going to look at a rough cut scenario planning capability, and that is I'm basically going to play the role of a demand and capacity planner. And what I'm basically going to do is walk you through an example of a data visualization using graph technology to be able to walk through a set of visualizations that will show how we can utilize some of the technology around graph to basically bring me visibility on if I have the right material at the right time. And that, in essence, is the pain point that a lot of supply chain planners are trying to try to alleviate, which is out of the sea of connected data, am I able to predict when I need the right set of materials, inventory for a factory, basically to to create the next set of components within that supply chain. In this case, we'll be looking at a manufacturing workflow. So I believe that the data set that we're looking at is basically consumer electronics. It can be applied to a lot of different use cases, but that is the use case that we'll be looking at. Okay, so this is an example of some data visualizations that we have on a manufacturing supply chain. So we're looking at bringing raw materials all the way through that supply chain to distribution centers as finished goods. Now, as Brian had mentioned, this is a planning process. So we're looking basically forward in time and trying to predict where we need, where we have resource bottlenecks potentially, or we may have anticipated shortages of componentry from an inventory standpoint at a factory level. And I'll walk through this as if I'm a demand planner, and I'll basically be showing some of the pain points that a demand planner may be able to alleviate by, first of all, getting visibility of the entire supply chain through capabilities such as TigerGraph to be able to stitch together a lot of this heterogeneous data into a connected graph, but also some of the techniques that we use at Expero to not only solve the technical scalability issue, but the cognitive scalability issue, where once you're able to utilize that technology, you still have to be able to slice and dice that data and traverse it in a way that's meaningful to the user that they can actually understand. So in this case, I'm going to go to a HighLevel dashboard first. So what I really want to see first and foremost is trends around my data set at a high level. I want to see at aggregate where I may have a problem. So I can look at this with some very high level measures. So I'm looking here at my product families and what that demand may look like over time for the projected future. I may look at what the revenue is in relation to those finished goods. So I can start to filter through this data, and I can see that for certain products here, they may or may not match what the ratio is on revenue, and I can start to at least get enough information to start to make the hard decisions essentially that I'll have to make when I have to trade off favoring one set of resources for another. Should I move my risk more towards things that may not have comparative revenue to demand, and be able to de-risk some of the things that are higher revenue. And so I can start to make those decisions at a very high level. And again, a lot of this is pretty simple aggregations bubbled up in trend charts, but the key here is that this stuff has already been stitched together as a connected set of data, which technologies such as TigerGraph allow you to do at scale. And even just taking a lot of the siloed data that has lived in legacy systems and pulling it together into modern technology from a data storage standpoint starts to unlock a lot of these capabilities where you can look across a supply chain looking at timescale data. I can start to see where some of my composite risk scores are and what my general trend might be, or what my threshold may be for those certain risks. So if I'm looking at inventory shortage or inventory overage, sometimes is a even more acute problem. We can start to attenuate that to map to the risk that the thresholds that our company has deemed as acceptable. We can also look at utilization of resources on a factory floor, being human resources or machinery that has to be allocated and scheduled to be able to make certain manufacturing runs. And we can see at a real high level where we may have problems. We can also see measure that up against the business side of things. Where are we not going to meet SLAs for certain finished good products because of anticipated bottlenecks? We can look at resource utilization by location, because there's always an asymmetry. We may have resources that are underutilized that are adjacent to resources that are overutilized, and just simply by being able to look at things over time in a predictive way, holistically, we can start to see where we may be able to make balances. So in supply chain, you really only have three choices at the end of the day from a planning perspective. You can either make more stuff, you can move things from one place to another, or you can cut orders. When you can't see things proactively, you usually have to resort to cutting orders, and that means not delivering on SLAs, and that means uncaptured revenue. So we can start to look to see where we can proactively balance things and either utilize the make more option or move things to rebalance rather than actually not delivering on SLAs or leaving revenue on the table. So real high set of KPIs. From here, we can start to filter down and make these charts potentially more meaningful. So we have the ability to look at consistent counts that roll these up even more over aggregations, and we can start to see trend lines over those. So if we want to see maybe a list of products that have inventory imbalances, meaning either too much or too little, in aggregate, we can start to look at that, and that gives us a clue into where we can start to rebalance. Same with resources, same with projected lost sales. So we can attenuate our the revenue that we're projected to not capture, simply based on the fact that we can project out how material is going to run through the supply chain. We can also start to look at that time series information. So this was mentioned by a couple of my colleagues on the phone here, that we can actually, we have the luxury of being able to aggregate up and see this graph data over time, which is a performance hurdle that legacy technologies often can't overcome. But now that we see that, we can bring this together in a meaningful way for the user, show demands over time, and see where our demand may be acute in certain places, how our KPIs measure up against that, and rebalance it. We can also cut this histogram at the bottom here over time by other values. So what's our production levels there? Are we having spikes in productions or valleys? What are our resource utilizations, and what's our on-hand inventory? At an aggregate level, this may give you some hints on where to drill in deeper. We can also attenuate our risk level. So we mentioned this chart before, but now it becomes a filter where we've got some inventory shortage that's very acute here. Our threshold is very low. We may want to come into the system and gain visibility over maybe one or two of these measures. Let's just say we'll take away overutilization, and we really just want to see underutilization and inventory surplus and shortage. Now, we can even tweak that threshold a little bit on some of those. And now we can kind of see at a very much tighter composite how we may want to measure risks. So we can also look at some value versus risk comparisons under some score charting, so we can see what the scorecard looks like for forecasted sales versus demand. We can start to run through some of the graph patterns that were mentioned before around matching and other algorithms that give us some hints that can bubble up to recommendations, as well as outlying risks for bottlenecks within the graph, simply by using some algorithmic graph traversal tricks that maybe a traditional SQL-based database may not be able to readily do at scale. So this is the very high aggregated level. Now we can start to drill into a level below, and we can look at a specific set of finished goods. So again, I have a set of KPIs that I can use for those finished goods. And then I have a list of finished goods that I can filter down on. if I just hide these here, I can maybe pick one of these that I want to drill into. And now we start to see visualizations that mirror a little bit more connected data, but still in a way that a supply chain planner may be able to understand this information. So this happens to be a bill of materials, and the color that you see corresponds to, in this case, inventory shortage. So we've got some coverage issues here. We can look over time and get that even tighter. So if I look at my time scale here, I want to see where there are acute demand spikes, and then that will start to change some of the componentry here. So some of the raw materials that roll up to that finished good at the top, I see that I have a problem. I can go ahead and earmark a few of those, and I'll show in a few minutes why I may want to do that. But basically what I'm doing here is giving familiar visualizations, windows into them for the supply chain manager to or planner to be able to manage. I can also look at the demand flow of inventory through locations. So what this will basically show me is how materials move through factories in the schematic. You can see how some things are flowing through maybe an OEM process to a compliance process through to assembly, and I can see that there are acute issues there as well that I may want to introspect. I can take this and drop it down another level and look at the factory resources, how this particular finished good flows through the factory floor and goes through mechanical resources. And in fact, here in this case, I have a capacity problem. So we are way overutilized on this assembly machinery. I can then go ahead and even look at that demand flow and something that can show how things flow through locations. And so all this connected data, again, is looking at something that is rather hard to do with tabular data, but as you can traverse, you can start to see some of the patterns that the connected data model in the graph look at. And so the next level down, now that I've kind of gone through a lot of these screens and visualized this connective tissue, now I can start to really drill in. And so if I want to see the relationships between maybe this one component that I've earmarked, I can do that. And now I can expose true traversal and start to look through the graph and see how components may be connected to, for example, certain scheduled runs or other components themselves. And we can even start to take that a level down and look at a detailed level how this connected information relates to each other in the graph. And then finally, I can start to pull a lot of that stuff together and show them as potentially rolled up reports, and all the things that I've gone through and looked at from a high level to low level perspective, I can pull together and now make it something that is almost like a living report that allows me to manage things over time as plans change, and as this projected inventory calculation from collaboration with different planners, things obviously change over time, both expected and unexpected.
So we'll leave it there for now. Make sure that Kevin has a little bit of time as well, and pass the baton over to Kevin.
Okay, thank you. Thanks, team. I'm going to share my screen now. Okay. So here we have Graph Studio, TigerGraph's visual SDK, where you can produce solutions without touching the backend. And we'll move over to the design schema page. This is the schema for supply chain. On the bottom half of the graph, we have a product, which, for example, is like a timing belt or car rims or a sunroof. And linked to it is the stocking, so with the inventory for the connected product. And right here we have site is where the product is created or made, or put together. And here we have P-order, which are orders for the specific product. On top half of the graph, we have vehicle, which contains a vehicle identification number, vehicle model, and the price of the car model. And connected to that, we have a service history. So for example, if you go get an oil change, you'll have this history in this vertex. And replacement parts, so like just like service history, if you replace a part on your car, like a tire or your bumper, it'll be recorded under replacement parts. And linked to both vehicle and product is our claim vertex. So you can file a warranty claim for a specific product, and it'll be linked to whatever vehicle that uses this product. So let's move on to the map data to graph. Since this is a starter kit, all the CSV files are already uploaded and the data is already mapped when you start an instance. So to load the data, all you have to do is once it loads, press this play button, which once it's finished, you'll be able to see that the files are finished, and you'll be able to see the status of the file with, along with the loaded lines and any errors that may have occurred. And you can also see the status of the entire graph, so the number of vertices and edges and specifics down below. So let's take a look at queries. So the first query we're going to look at is called minimum buy. So in the car world, manufacturers make deals with part suppliers to buy a volume of parts to keep costs low. The car manufacturers are actually bound by contract to the suppliers to purchase a minimum number of parts. And if this contract is not fulfilled, there's probably going to be monetary penalties for the car manufacturer. So what this query demonstrates is, let's say, there's a number of parts the dealership needs to sell. So we'll be able to calculate how many vehicles of which types to sell. So let's say we need to sell, let's see, for how many sunroofs we want to sell. What will return to us is you need to sell 1,000 cars of these types. And since you need to sell cars and not just the raw parts, it'll list out the types of cars you need to sell. They're not actual cars, they're just fake, because this is just fake data. So we need to sell 1,000 of these, either of these types, or a combination of these two, reliable and sports car. And the second query we're going to look at is called recall products. So what this query effectively does, it takes in a certain claim for any product or car and returns a list of vehicles that use this part. So with this, car manufacturers would be able to detect and probably send out recall letters to the many owners of the specific cars. So let's just take one for example. We're going to run on this small data set, let's say claim ID of 30. And what it will do is show you the product that is that is the topic of the claim, and the vehicles that are related to this claim. So all these vehicles also use the ABS module, which is probably a big deal if you have a recall for that. So you probably want to take it into a shop. So yeah, that's all I had for today, and I'd like to hand it back to the Expero team for further.
Okay, we'll see if we can pop up a couple more slides, but just wanted to wrap with some, what next, what can we do, and how can we get connected and involved. And so one of the things that we very commonly do is prototypes and proofs of concept. And in some cases, our customers have and our prospects have a very specific use case in mind. They know a big challenge that they have, and they have some sense for how to go about tackling it and making the business case. And maybe they just need some bandwidth or some technology expertise in order to help with that. But in a lot of cases, there's a sense and maybe even an understanding that graph can help, and how to go about and which problem to tackle first isn't necessarily that clear. And so we have a number of different courses that we typically use. We can start with a very quick kind of a discovery session. And these, as you might guess, kind of build on top of one another depending on where exactly where exactly you're at in your process here. But it can range from a quick discovery on into a workshop where we sit down and look at a problem and look at data and talk to users, and then turn that into a very distinct set of outcomes that we'd be looking for, and then if we can prove out, we'll show that there is in fact value in tackling this problem, in bringing in graph, in visualizing a new interaction, and we can show that quickly and generally and pretty inexpensively, and validate that in fact moving forward with a project and a new software and some new interactions are going to actually improve the business, and they're going to have a very clear ROI. And so typically the outcome of a proof of concept is an ROI, where we can demonstrate exactly the value to the business, and we can see where moving on with technology will yield some better outcomes. So that's typically how we engage. We've got some links here to share as far as interacting with either Expero or the TigerGraph counterparts here, and I'll turn it back over to Gaurav.
Yeah, so Expero has been a great partner with us in multiple large and mid-size accounts. So regardless of the size of your problem, please contact us. Please, the starter kit that you saw, the supply chain 2.0 starter kit, we'll be adding that later this week. So we'll send out a note to all of you, informing you that the new starter kit is available. There's already an existing starter kit called supply chain analysis, but this will be a more of a advanced supply chain analysis starter kit. And we'll keep on adding more and more information to these starter kits, and we'll publish that to you. If you haven't tried already, please go to tigergraph.com/cloud and start to experiment with the cloud. You don't need a credit card. You can start it for free. Play with the current supply chain analysis starter kit, as well as the supply chain 2.0 starter kit that will be added later in the week. And come back to us with your questions. We always encourage questions from you. Let's see if we have a few questions today that are part of the existing footprint. I see one question here. I have an existing supply chain management solution. I've been using it for several years. What value can Expero and TigerGraph bring to that? Let me address it with a customer example. We have most of the customers we walk into, whether you are an industrial manufacturer, whether you are a distributor, or you are an automotive OEM, you have existing solutions that you're using for planning your parts, for planning your production. What we provide is the ability to connect that solution with all the other solutions that you have. So whether you're looking at the example that Kevin mentioned, right, where you have excess inventory left for a particular part, like a sunroof or a moonroof from a vendor that you need to consume, or a particular type of accessory that you need to consume, you're not meeting the volume commitment. We can connect up your existing supply chain solution with your vendor commitments and essentially connect the dots between those and help you understand where you are you're likely to have run into penalties at the end of the quarter or at the end of the month. And we'll make sure that that can be addressed with recommended promotions that would absorb that excess inventory. So those are the kind of things that you can do with the existing supply chain solutions that you by connecting those with other systems, like the vendor contract system, for example, that you cannot do currently, or you're trying to do it in a data warehouse and it's very long and slow and tedious process. So many of our customers that see weeks and weeks of this analysis being shrink down to a few minutes, and that's where we can accelerate your supply chains meaningfully. Let me ask David, are there any other questions that we can address?
Yeah, I think, can you hear me, Gaurav?
Yeah, you're good.
Yeah, great. Yeah, we have a couple more questions, and this first one might be suitable for either Brian or Chris. The question is, what are the unique benefits and challenges of modeling the supply chain in a graph? So either Brian or Chris, if you wanted to take that one.
Sure, this is Chris. I'll take a shot at it, and Brian maybe can add his 2 cents. So the benefits are that at scale, you can show the data more closely, or you can you can store the data in a way that more closely resembles how it's modeled in real life, which essentially is a chain or a dependency graph. You can start to expose some of the connections through the various parts of that, and you can traverse it in a way that makes sense, as well as utilize a lot of the algorithms that graph-based data affords you. I think some of the challenges are being able to take legacy systems where that sits maybe in relational tables or even flat files or Excel files, such as Brian mentioned, and being able to model that and then ingest it into graph-based storage solution. And luckily, I think that's where TigerGraph and Expero could help with that process.
Awesome. Here's another question from the audience. Are there areas of supply chain other than planning where you have applied graph?
I can jump in with that. This is Brian. I'm sure you guys have some experience on your side as well, but we've used it in scheduling. We've used it in routing. We've used it in a variety of contexts of optimization and forecasting, just from the perspective of, yeah, there might be some additional technologies as well, and there's a way to apply machine learning and AI to some of these situations. But in bringing that data together, there is a lot of advantage in how you tackle it. So there's a lot in the logistics and transportation space that we've done. We've actually used it in optimizing locations of distribution centers, just in the fact that we brought all that data together in a graph in order to make sense out of it, and then into analyzing it. So those are some of the other cases.
Excellent. Okay, thanks, Brian. And last question I see here in the chat panel is, how do you integrate with legacy systems?
Sure, I'll jump into that as well. The application actually that you saw here from the Expero side, it's effectively data source independent. We can take from more than one data source. I think, and this goes back to one of the earlier questions as well, this doesn't need to be a replacement solution. In many cases, this is something that can very easily layer on top of, this is not going to replace SAP as an example, right? This is something that layers on top. The problem here is disparate data sources. Bringing in TigerGraph allows a centralization point for a lot of that data and a lot of those relationships. It doesn't even necessarily need to be all of the data in order to then apply the value of graph, bring in some of that peripheral data. But we have a variety of ETL layered tools that we have to help connect with all these data sources and then bring them into a central point for analysis, but layering on top without having to replace them or to rip them out. So,
okay, awesome. Yeah, thanks, Brian. Well, I think that brings us to the end of the webinar. We've run a wee bit over time, but hopefully it was informative. We know that all of the audience are busy, and you had many choices on how you could have spent the past hour, and we're flattered that you chose to spend it with us. We hope that you found the webinar informative, and we hope that the enthusiasm from the Expero team and from the TigerGraph team has been contagious. And we do these webinars roughly every week, so please keep a lookout on our website for an upcoming Graph Gurus. So that brings us to the end of the webinar, and I want to thank you all for attending, and I want to thank my colleagues Guraf and Kevin, and Chris and Brian from Expero for their excellent presentations today. Thank you.